Alrighty, just got done building the relay board. This is an RF man relay board. Very nicely done too. I like it. Working just perfect. That right there is a little bit less than a half a watt. With a 29 picofarad coupling capacitor. All I gotta do is add the wires right there for the sideband delay, and just want to make sure she was working before I mounted her. Alrighty.
But he really didn't do anything.
Alright, brother, we got this thing
and went over and looked at the
coming together here.
The flame was no longer flickering.
Got the
it was essentially
amp shunt mounted,
the way it was. Frozen.
Wired up to the plug.
The candle was there, and the flame was like a two-dimensional picture of it. Oh my God! And it wasn't.
Got the power supply mounted.
But it was still emitting light.
Got on the wire near around.
Well, it could mean all kinds of things.
Put a little trigger out there just to make things a little easier when I plug up the 110 in the back and just solder it straight to there. I love them trees, man. So we now got all the switches are all wired up as soon as I solder this last point here, which is bringing the 12 volts to the switch bank to then control the relay and everything. And we'll bring two wires. We'll bring another wire off the supply for the bias and for the fans as well. So we'll bring all that off that. So it's coming together, man.
How the emitters can focus gravity, because
hopefully we'll have this thing done by October sometime, I hope, but we'll see. See how things run. Alright, brother. Well, we got the coax on the input. Input and the output. Created me a ground plane right here to clean things up. This grounds to the board, which grounds to the case. So we won't be having just a big mess of coax all over the place right here. Went ahead and tuned it out because of the extra inductance of the relay. We had about a little bit of quarter of a watt or so of input reflect, 5 watt slug reverse. Now we have I call that technically a perfect tune, 1-to-1 going through. There's your input. Excuse me, not your input. Here's your feed through tune. 50 ohms through the relay. Alright, brother, working on these dang heat spreaders. I tell you what, man, using a hand drill, or actually 2 hand drills, I kid you not, about 4.5 hours it took me to finish these things, man. And I'm not done yet. I still got to tap the number 8 holes. Just going to be mounting the actual heat spreaders down. And broke one bit, which is good. Usually break a lot of bits. Messing with this copper if you ain't got the right kind of bit, but it ain't the easiest thing to work with. Gotta always make sure you get some good cutting oil messing with these things. But yeah, so I'm gonna clean up all these little copper shavings, man, and drill and tap my number 8 holes and take these things in and wash them real good and get them scrubbed down. I'll be back, man. This thing's coming together. Will it be done by Halloween? I don't know. We'll see.
Fair enough. The photographs are very, I agree, look, they're very impressive.
If you've got a guy who's showing you pictures that he's taken of Disneyland, on the ground.
All right, brother.
Oh, those I've got.
I want you to know,
I'll get them to you. You know, I'm just glad that
it technically has took me all day just to get these copper spreaders drilled out, heat sink, everything mounted to get ready to mount the boards.
we've both just been so busy.
Oh my goodness, it ain't the easiest thing to do with just a hand drill, I'll tell you that.
Okay, well, look,
Good God Almighty. I don't think I'll ever do this again, honestly. I'm going to either get them drilled out for me or wait until I get me a good drill press before I actually do another one of these. So anyway, so we're about to
I met Carlos Diaz.
about to go ahead and mount the boards.
And Carlos
Got everything mounted down.
As far as the scientific community is concerned in Mexico,
It's looking good, man.
Carlos Diaz
We'll
is
be back.
presenting some of the finest.
All right, Mr. Spaceman. We're back here. I've had some major video camera malfunction, and I have possibly lost a couple of video clips of the building of this. So if that is so, I highly apologize for it. I've got a new computer since I started this build, and a new camera. But anyway, I think I've explained all that to you. But that may not be may not be so. I'm gonna have to wait till I get all this compiled and everything. But I need to hurry up and show this beaut to you here. I know you waiting to get this beautiful amplifier here. I know you've been waiting for a little bit. So basically, first off, what I've done here is I have recreated the attenuator here. All right, what we're rolling with is a 10 dB attenuator, okay, made with carbon 5-watt resistors. I'm gonna play around with these in a little bit and drive a 1-pill in them, just kind of curious how they're gonna do with heat and everything. But I think it turned out really well. I went with a narrow banded LC circuit design, kind of like you'll see in some of the BJT style amplifiers, since I know you're going to be running this just on one band. If you were going to be running this on multiple bands, I would have went with a hybrid coupler combiner and splitter. So there's your splitting network right there. Right here by the relay board. This is a RF man relay board right here. Saved me a little bit of time. They're actually real good quality. To make sure I make sure the way the RF is being carried from the input, output, and all around the board, I wanted to be done with coax to keep everything at 50 ohms as much as absolute possible. So I've got all these, the coax are all sharing the same ground. As you see, I've got a copper board that's wrapped around the relay here. They're all sharing the same ground. This is grounded directly to the box there. But this right here is your input mini coax. Travels right into your attenuator right here. Alright, RF travels through these four, which is around 25 or so ohms. Shunt with 3, around 35, another 25 equals you 10 dB, negative 10 dB attenuator, and then picks back up right here onto your input splitter. There's your surfboard right there. That's the name of Mr. Big Danny at 123 calls them surfboards. That's actually a pretty cool little name for them. But we got this bad boy tuned out. I mean, virtually perfect. Virtually perfect. And then here's the output. I wanted to go ahead and go pretty hefty on the cores. So these are, I know, way bigger than really need to be. This is a 61 core. So I'm glad I was able to find these. They wasn't the cheapest things in the world, but this is the first time me combining two LDMOS pallets with an LC type circuit. I think Mr. BBI has, if my sources are correct, I believe that is one of the ways he was combining some of the first LDMOS boxes he put together. I've seen a picture of one. Actually, somebody sent me a picture of one a couple days ago, and yeah, that's what it appeared that he was doing. you've pretty much got about 3 different ways you can combine these bad boys. Two are narrow banded, one's wide banded. You got a hybrid coupling style design where you just combine everything and throw it into a 2-to-1 auto transformer. Then you've got the 2 narrow banded methods. An LC circuit like you see here. Some people may call it an L, but it's technically an LC circuit. Series L shunt C. Series L, shunt C, Series L. And then you've got a Wilkinson combiner, a lumped Wilkinson combiner. I was actually thinking about using that style with this, but I just went ahead and went with this. I still need to get me a, well, I got me one now, but at the time I didn't really completely trust my LCR meter. Let's see here. I think I done put that joker up now. No, there it is. I was using this meter right here, but wasn't completely happy with it, so I went ahead and threw some bucks together and got me a really good high dollar LCR meter. One of these DE5000s. Oh my God, I love this meter. Oh my God. You can only trust yourself as much as you can trust your instruments. If you can't trust your high precision instruments, I mean, you can't trust anything you're doing. All right, let me carry on here. Let me go ahead and explain why I decided to leave these trimmers right here. Because as a lot of y'all know, Gatekeeper don't ever leave a trimmer in a box. I love taking them trimmers out and miking them in so people won't be in there playing around with them. Well, I had a little bit of a vital issue going on here because you're dealing with so much RF in a binocular design like this. You need special caps. You either need to, well, you're going to have to series some 500 volt caps or use some 1000 volt caps. And the place where I got my 1000 volt caps had shut down, so I didn't exactly have enough time to get a good load of them in, and the ones I had here wasn't the right value for what they tuned out to be. Next is using metal clads. Now the last LDMOS box I put together, I use metal clads, just series 2 metal clads together, make them a 1000 volt part, but it just wasn't working out for me. I'd sit here and tune one board, get the corresponding caps, series them together, mount them, and it wasn't showing the same tune. It was getting on my nerves a little bit. I had done soldered about 3 separate metal micas, and it just, I would sit there and tune. These are a little precise when it comes to tuning these things. There's some designs out there you don't actually have to use a compensation capacitor on top right there, but I'm just going to play around with that a little bit more in the future. But these right here are way more than adequate. These are 1800 volt parts. These are trimmers that you'll see in a lot of tube type boxes. They are way more than adequate to leave on here. You ain't got to worry about them blowing on you, etc. Don't get in here and try to start twisting them around and turning them or nothing. You know, they're tuned out. They're good and sturdy. And I was able to get both the boards completely fine-tuned perfectly. You know, if I'd have spent more time and had a lot more metal clads laying around, I would probably would eventually got it. You know, it's just weird how fidgety these things can be sometimes when you're tuning them. I mean, you can add a little bit of length to your capacitor and gain another capacitor's legs and gain another 100 watts. It's pretty crazy the way that works, but this works out perfectly fine. So this is actually 800 volts more than what I would have been using. So this is a one exception. So I got an exception with this, and whenever I'm building a tuned circuit 1 transistor amp, which I haven't built one of them in a while, those are the same way. You get them just a little bit off in capacitance, they're not working the way they're supposed to. So anyway, that's what we're rolling with. I just noticed I need to take that marker off right there that I use for measuring. That's what, when you get done with a build, man, I like to just sit here for about 10, 15, even 30 minutes and just look at everything. Make sure there ain't no pieces of solder in here. Make sure everything's good to go. I always like to do that. Sometimes I'll do it 2 or 3 times because you just want to make sure this thing's right before it leaves. And got your supply there. And about the amperage meter, there's your shunt right there. There's your meter. I had a little bit of bad luck building this box. As you know, the first time, the supply. These are the supplies we're using. These tanks right here, man, these are really getting hard to find. These are the ESP120s. Freaking tanks, man. I wish I'd have been buying the heck out of these when I first learned about them, because they are getting hard to find. The first one that came in here was not working completely. And I think I've bought about 8 of these so far, and that's the first issue I've had, so I had to purchase another one, which is this one. But then I had some issues with this. Meters. These 2 meters come in, which I was going to be using one, and they flat out don't work. Broke. These are always sitting right there on the tin, which is way too far to correct. So those were damaged upon shipment. And the meter that I was planning on using, which was this one, 50 amp meter. These are more of the high dollar ones that cost about 12 bucks a piece. A lot of the other ones can get down to $3 or $4 a piece. And then this meter wasn't working correctly. The amperage was just not reading properly. I'm like, I'm just having some luck here. Bad luck. So luckily, the last one I had here to use, I'm glad I bought a couple of them. That's why I like buying a couple of things, man. You never know. Luckily, this one worked. So, that's a 100 amp meter movement. Question, how do you know when you're overdriving this puppy? Simple. When you reach around 50 amps. If this was my box, I would let this thing cruise around 40 amps. Just leave it be, man. These things you can definitely overdrive these things very easily. A lot of builders that still mess with these boxes already know. I've heard horror stories. I've heard complete anxiety just flowing around builders because of the people getting the boxes, overdriving them because they want more power out of them. Pop. Because you can take a BJT amplifier and overdrive it 50% more than it's supposed to be. Sometimes even 100. And the thing still, a great chance it's still going to be working. These are not like that. Other than that, these things are indestructible. That's why in here in the future, if I do plan on to work with these a lot more in the future, I'm going to implement some sort of overdrive circuit that shunts to a 50 ohm load if you're overdriving it. It's going to be a whole nother thing there. So anyway, that's why these meters, if you ask me, are a must to have a amperage meter with these boxes. Keep her around 40 amps, man. I mean, yeah, you can get a little more out of it. I think if I remember correctly, you're probably going to be using this as a driver, so you're probably not going to be using it to its maximum anyway. But anyway, all right. Since I can't get in here and show you what this shunt is doing by itself, let me give you an idea. All right, as the box sits right now, just driving it with this radio, she's doing about 250 bird RMS, about 500, 600 watts PEP with a half a watt of drive, which is absolutely amazing. All right, here's what we're looking at. I guess I can take this down now. I got that short-term memory crap. So I love to draw diagrams. This is a diagram, a pictorial diagram. It looks like it's third grader drew it. of your amp, which just keeps my mind straight while I'm working on stuff, man, so I don't have to keep all of it up in the old cranium up here. But anyway, 5-watt slug. Alright, so we're right there in the middle. A little bit under it right there, about a 1-watt dead key. A little bit past 3. Usually it's about 3, but about 3.5 watts RMS. Which comes out to about 18 watts peak. Alright. That's just showing you the input of the attenuator. Audio. Absolutely no movement. That lets you know that this attenuator is built the way it's supposed to be. If this attenuator wasn't built the way it's supposed to be, or you're using the wrong type of resistor, etc., you're going to have some input reflect coming back to you, and you're going to have some reflect on the other side of it as well. So that's good to go. Now, that was 3.5 watts RMS. Okay, what is it giving us? 3.5 watts. We're on a 10-watt slug. I ain't got another 5 handy. 10-watt slug, bottom scale. That 20 is 2 watts. Now this is flowing through this attenuator. It's a little test attenuator, just so I can show what the box is getting. So it's coming from the radio there, flowing through the attenuator on up here. So that 3.5 watts is turning to 1/2 watt. 20 is 2 watts. In between that's 1 watt. 1/2 watt. PEP. A little bit over 2 watts PEP. Alright. Let me get the box hooked back up, and we'll let you see what it's doing. And then next, I'm going to have to simulate your drive conditions. Okay, you've already let me know about what you're going to be driving into this box. So basically what I need to do is I need to take some of my amps up here, maybe a 1-pill, or find the right combination of what I've got here to use to get near your working conditions, and show you what the box is going to be doing. Now the way it sits, it's pulling about 18 amperes on the meter, right there, about 18 amps with a 1/2 watt of drive. You should not have to push any more than 3 watts of drive to these two boards, really. You really shouldn't. I mean, you got a little bit of loss in the combining network, splitting network, yes, but you really shouldn't. But we'll see what she does. And I'm just happy the way it turned out. I mean, this thing's built like a tank, if you ask me. I'm real proud of it. It's beautiful too, man. You did a good job on the paint job. Mr. Spaceman's been waiting a while. I know he's gotten a little bit frustrated with me, which I completely understand. If I was waiting as long as he had, I'd be frustrated too. I'd probably be ready to put them dupes up. You know what I'm talking about? But he's hung in there with me, man. And I know it'll all be better when he gets this butte. Alright, we'll be back. Alright, brother. Well, here we go. Make sure this thing ain't zoomed in here. Ain't zoomed in, the amps are so damn big. There we go. Man, this thing is beautiful. Every single candy paint amp I get done with, it just never gets old. Alright, brother, we got a little problem here, man. I am unable to produce the exact power that you're going to be using. I need to get me another radio up here. What I need to do is get me a ham rig and get a ham rig mounted up here. One that I really can go from about, I'd say about 100 watts down. I got a 1-pill over here, but it's still a little bit too much. for it. So I'm just going to use what I have. We're going to go from radio to radio and just show you the curve. Here's your amperage meter right here. Now the only thing I did not think about with your power supply, and by the way, this is the 4th power supply I've used with these ESP120s. These things are tanks, son. Tanks. But this is the first one that has been a little bit more sensitive to the RF. So I had to put a couple of beads on here, man, and as soon as I put them on there though, it fixed it right up. It's just I've heard that some of these are a little sensitive to RF. I know a guy that combined 2 of them that had to build them I think he built them I can't remember what type of choke he used, honestly, but I've combined 2 of these and didn't have any issues with those particular ones. But this particular one's a little sensitive to RF. I don't have an extra one laying around because actually the first one that we were using had an issue. So this is the replacement for that one. So I don't just have a lot of these ESP120s laying around, but ain't no biggie. I'm gonna let you have these beads. I just put a couple of beads on it, man, and it fixed it right up. And so anyway, so you know how much I'm about to be putting in here, because it's exactly what, now the other video clip I did earlier was a couple of days ago, but you saw how much tiny power was making it through the attenuator with my first bench radio. So that's what we're driving in this thing now. Alright, just so you can see the flow through. Oh, it is virtually absolutely flat. Oh, yeah, I had to throw a capacitor on there to do that. Alright, got a 1000 watt slug right there, that's RMS. 1000 watt slug at that PEP. This is just for that small amount of power, single final Cobra 29. Oh, yeah. That's about 850 watts or so, PEP. Oh, a little bit over 200 watts RMS. On your amperage meter, oh, it's about 16 amps or something. Now this meter is very important. Yes, I know you're going to be using this as a driver, so you ain't going to be pushing it to its max, I don't believe. But if this was my box, I would try to keep the thing under 40 amps. That's just me. Alright, well I'm using my phone now. My SD card ran out, that bad boy right there. And I'm going to go ahead and send this home with you right here. It's just a little 10 dB attenuator you can kind of use to kind of gauge how much power you're going to be putting into the box, since that right there is the same exact attenuator that's in the box. Okay, so anyway, yeah, if it was mine, I myself personally would keep it around 40 amps, no more than 40 amps. That's just me personally, you know. A single device can do up to 30 amps, it really can, but me personally, that's just my personal choice there. Just I don't like to overdrive my amps, push them too hard. That's something I had to grow into though, fellas. I didn't start off that way. Alright, man, let's hook up the next radio. Alright, this is the Stickman Cobra 29 up here. Alright, and it does about 8 watts RMS, about 20 watts, 40 watts peak. Okay. 1000 watt slug, PEP. Do, just off the scale, RMS. Do, right there, a little bit over 400 bird. So, you need to put the 2500 watt slug in. I'll be right back. Alright, just get a little bit clearer picture on the PEP of that 2500 watt slug. Top scale. So that's about 1400 watts PEP. That is something else, man. That is banging. I can't tell you exactly how much power that's actually putting in the box because I didn't hook it up through this at first, and I don't really have time either. Right this second during the video, I'll hook it up afterwards. But all right, on to the next radio. Like I said, I've been meaning to get me a little ham rig to hook up here, man, that I can actually control from 100 watts down to 4, to give me a lot more control over that edge for these LDMOS amps for showing them, because different people run different things, and the amount of power you're running on your end, I can't exactly produce it. I don't have your exact radio here, and my radios don't do that much. And my little small drive over here is a bit too much for that, and I ain't gonna be. It's one thing you don't want to do is overdrive this bad boy. Other than that, man, the thing is like almost invincible. Woo, boy, that thing's pretty. I'll be back. All right, brother. This right here is the D-rail radio. So now we pumping up about 16 bird. God. Oh boy, and I think the peak watts is somewhere around 68. I ain't hooked it up in a while. I can't quite remember. I ain't hooked up the old D-rail radio in a while. I ain't been hooking up working no amps to run it with, honestly. But this right here, I think maybe a tad bit too much for it, but I'm not 100% sure. All right, 2,500 watt slug and peak. Ooh, God. 1,000 watt slug RMS. No, right there about 800 bird, man. I'd say right there probably about 800 to 1,000 RMS is probably going to be a kind of a sweet spot when you're looking at the RMS side of things for a dual LDMOS. I'm going to go ahead and tell you, brother. This is why. Now, a lot of people out there may already know. A couple of people have been waiting on me a while. I've gotten quite behind on my work. And this guy right here has he's hung in there. He's hey, he ain't killed me yet. That's all I can say, really. I ain't gonna add to it or take away from it. The fella ain't killed me yet, so that's a positive. So I'm just glad to finally get this thing done. And this is one of the major things I wanted to see, and why I really kind of asked him, can we just do 2 singles? Because we were going to do a single dual board, 1 pallet with dual devices on it. And I've kind of been having a little trouble getting a full 3 kW or even 2,500 watts out of the dual pallets. But I was real curious if I'd be able to get a little bit more using singles. And I've seen Mr. BBI over there, Mr. Luke Miller, out there in the Idaho area. I've seen that he runs singles, and I've seen some other guys running singles as well. And there's a reason for it. There's a reason for it. And I think that's probably going to be the best bet. There's other logical reasons for that as well. Just with the impedance. I don't know, something got my attention over there on the computer. And I'm designing a little piece of software that's working for me over there, and it doesn't seem like it's. Just press stop on that right there. Well, anyway, I'm really glad that I was able to get this project done with 2 single devices, because already I think I've already done 2 projects with dual, a single board with 2 devices on it, and this bad boy right here is already doing more than that. I think I've been able to get maybe 22 to 2,300 watts out of a dual board like that. And as you saw it just there, just hit the corner, 2,500 watts. And like I said, I don't quite know exactly what's actually making it to the amp. I'd have to hook it up to the attenuator there. But I don't see why this bad boy won't do 3 kW. But hey, 800 bird. Drive this thing a little bit harder, she'll get up to 1,000. I personally wouldn't run it no more than 1,000 watts RMS for a dual device. I'm still learning a lot about these things, man. I'm not going to sit here and tell you I'm a wizard with them, because I'm not. I'm still learning. So anyway, thanks. I don't know if I'm going to be taking on any more of these right now. I got to get the rest of my transistor BJT style amps done. And we'll see. We'll revisit the idea and see. Because, I mean, it's been fun learning them. And I'd really like to do one for myself. And I do have a little something put up for myself. But we'll see, man. We'll see what the future holds, y'all. Because the old GK has now gotten to cryptocurrency trading. Bitcoin, baby. Getting down with the get down. We'll see ya. GK out here around the northeast end of Georgia. Hey, Spaceman, appreciate you for not killing me. We gone. Bye-bye.